Hello, my dear students. In the last session, we have discussed the comparison between step index fiber and graded index fiber, as well as we have seen that how the light travels through both of the optical fibers. Now, we will focus on our next concept, that is acceptance angle. Now, see, this one is a much important concept while understanding the optical fibers. Before understanding acceptance angle, we will understand what is meant by acceptance cone. Now see here, I'll draw the step index fiber. So here, this is the core region of optical fiber, that is step index optical fiber. So this one, again here, like this. Now this is the core of step index fiber. Now here we'll draw the axis of that particular core medium. So this is axis. Now we will consider two different arrays which are coming into this particular core section. Before that, let the refractive index of this core, let it be mu1, and then beyond this there will be cladding of a refractive index mu2. Again here we have considered the step index fiber. So the refractive index of core medium, it will be constant throughout the section. Now see here, if we consider two light arrays like this, so now consider two light arrays like this. Suppose this one is the first one which hits the core axis over here, and then again it will, as light is coming from a rarer medium towards the denser medium, so this light will bend towards the normal. So let it be like this one. This one is the refracted one. Here we can draw one normal. Suppose this is n, and let this angle of incidence be theta 1. Now in the same way, we will draw another light ray which is coming from this medium, or like this one. Then again, as it will hit the core axis, it will bend again towards the normal. So it will be like this. Over here, again here we will draw one normal, and then this is the angle of incidence. Let it be the same, just like the previous one. Now see, as we know that for total internal reflection, this angle of incidence must be greater than the critical angle. So here we'll write like this. This theta 1 has to be greater than the critical angle, that is theta c. Why? Because then and then the total internal reflection will take place at these particular 2 points. Let we label them as point A and point B. Now listen very carefully, as we are assuming that this is the minimum angle. This theta 1 is the minimum for which total internal reflection is takes place. So if we increase this particular angle theta 1, then definitely there will be a total internal reflection. So when this theta 1 will increase, now simply just imagine that light is coming from this way. See, focus on the arrow. If light is coming from like this one, here it will go like this, and then it will be just like this one. So for this particular path, the angle theta 1 will be greater, or here whatever will be the angle of incidence is, that angle of incidence will be greater than this theta 1. That means what? It is greater than the critical angle. So there will be a total internal reflection. Then again, if we consider another light ray which is coming outside this particular ray, or from here, if you consider, simply follow the arrow. If it will come over here, and then it will be hit just before this point B. And then for this particular angle here, the angle of incidence, it will be less than theta 1. So that means what? We can confine the region. Which region? This one, this particular region here. Here I'll make one cone. So here now we can say that the light which is coming inside this particular cone, and then it is reaching at this particular core axis, then whole of the light after refraction, the angle of incidence will be greater than the critical angle, and then definitely there will be a total internal reflection. Also here, if we draw, we can draw two rays, light rays over here. See, like this one here, suppose this is the light one here, then it will be beyond this point B, like this here, and no doubt one can easily say that this angle will be greater than theta 1. And now we are considering another ray which is coming outside this particular cone here, and then it will be bending like this. So it will come at this particular point. No doubt this angle will be less than this theta 1. So here, for light ray which is coming outside the cone, from outside the cone, the angle of incidence is less than the critical angle. So there will not be any total internal reflection for this particular light ray. Here we will label it as a 1, suppose, and this is as 2. So here we can conclude that the light which is coming from outside the cone, the angle of incidence for them in the core medium, it will be less than this critical angle. So definitely there will not be any total internal reflection over here. But if you consider this second light ray, which is coming from inside the cone, for this particular ray, this angle of incidence is greater than critical angle. That means what? For this particular light ray, there will be a total internal reflection. So here, the final conclusion will be what? All of the light rays which are coming from inside this particular cone, for those light rays, or they will follow the total internal reflection, and then the light rays which are coming from outside this particular cone, for them there will not be any total internal reflection. So we can say that that will be the, simply it will be wastage. How it will be a wastage? See, here I'll draw another ray. Suppose this one, this light ray is coming outside from the cone, then it will get bent towards the normal like this. So here at this particular point, if we draw the normal, this angle theta 2, let it be, this theta 2 is less than theta 1. That means what? There will not be, see, as it is less than theta 1, let it be, it is also less than this particular critical angle theta c. That means what? There will not be a total internal reflection, and this particular ray will go into the cladding like this. Again, as we know that here refractive index of core, it is greater than that of cladding. So definitely this light ray will move away from the normal. It will move away from the normal. That means what? It is going straight away into the cladding. And as this light is going into the cladding, that means what? It is simply a waste. It is none of use. So here we can say that this particular conical section, it is accepting the light which will go straight away through the optical fiber, and then it will reach its destination. So here this particular cone is called as a acceptance cone. It is called as a what? Acceptance cone. Here you can write it as a acceptance cone, because see, the light rays which are coming through this particular cone, the optical fiber is accepting, or it is allowing all the light to pass through them. So that's why we called it as a acceptance cone. Now we'll see what is meant by acceptance angle. Here I'll extend this particular axis like this. So this is the axis of core. Now see, now what is meant by acceptance angle? See, it is the maximum angle made by this particular cone. The maximum angle made by this outer portion of the cone with the this particular core axis. So this angle between these two, this angle is called as a acceptance angle, and let it be denoted as a theta, and then here we can write it as a, or this is simply nothing but the acceptance angle. So now we can define the acceptance angle as the maximum angle with axis of core at which the light can enter and propagate through the optical fiber. See, here I mentioned it as a the angle at which light can enter. That means what? See, here light will coming from any of the end. Definitely it is, or it will enter into this particular optical fiber. But but the light which is coming from outside the cone, it will get refracted into the cladding. It will not be able to propagate through this particular optical fiber anymore. So that's why here I mentioned the maximum angle with axis of core at which the light can enter as well as it can propagate through the optical fiber. That particular angle is called as a acceptance angle, or sometimes we called it as a semi-conical angle. We also called it as a semi-conical angle because it will be exactly half the angle of the cone. So that's why we said it as a semi-conical angle. Now we will derive the mathematical expression for acceptance angle. Suppose you see this one is the basic diagram of optical fiber. Here if we draw a light ray, see this one is this is again core medium of refractive index mu 1. The refractive index of outer medium let it be mu naught, and that for cladding let it be mu 2. These are the refractive indices of these three different media. So here consider, suppose this is the angle, let this angle is acceptance angle which is denoted as theta naught. Then this particular light wave it will get refracted like this. So here this is the refracted one. Here we will draw one normal over here. So this is the normal. Let this angle of incidence let it be theta c, that is critical angle. And then we know that when light hit the wall at an angle that is which is equal to the critical angle, the refracted ray will be perpendicular to the normal. This is normal. So this angle will be 90 degree. So now here we can write this theta naught as theta naught is the acceptance angle. Then this theta c, it is what? It is critical angle. And then this mu naught, this one mu naught is the refractive index of medium where this optical fiber is been kept. Then this mu 1 is the refractive index for core medium, and this mu 2 is for cladding. Now we'll derive the formula for this theta naught, that is the acceptance angle. See, here for this particular phenomenon, there is the refraction at 2 points. So first initially light get refracted at point A, and then later on it get refracted, or there is a refraction at point B. So here we will use Snell's law for at these 2 points, that is point A and point B. So here you can write, see we know the Snell's law. It is what? It is sin I upon sin R is equal to the mu 2 upon mu 1. This is the basic general formula. So now for a refraction at point A, we can write this equation as C. At refraction at point A, for that the angle of incidence is nothing but the acceptance angle. So it will be sin theta naught divided by this angle. The value of this angle will be, see it's a simple mathematics. If you see this angle or this particular triangle, so let it this point be O. So this particular triangle AOB, it is what? It is a right angle triangle. So no doubt if this angle O, this one it is 90, this angle B is a theta C. So ultimately this angle A, it will be 90 minus theta C. It will be what? 90 minus theta c. So here we can write this one as 90 minus theta c will be equal to here mu 2, that is the refractive index of second medium. Or see, instead of to avoid the confusion, we will use the notations here as n2 upon n1, because we have already used the symbol mu1 and mu2. So just make it as a n2 upon n1. So again, n2 is the refractive index of second medium, and then again n1 is that of first medium. So here, for this particular first refraction at A, the second medium is the core and the first medium is the outer medium. So here we can write second medium, that is mu1 upon what? It will be mu naught. So now here we'll write this equation as, here let it be, therefore this will be mu naught into sine theta naught is equal to this mu1 into sine 90 minus theta c. Again, we can write this equation as mu naught sine theta naught is equal to, this is mu1 sine 90 minus theta. It is what? It is cos theta. So this will become cos theta c. Let this be equation as equation number 1. Further, we can write this equation as mu2 sine theta naught is equal to this mu1. For this cos theta c, we know the basic fundamental identities, that for cos square theta, we can write 1 minus sine square theta. So here, for cos theta c, we can write under root 1 minus sine square theta c. So let mark this equation as equation number 1, this one. Now we'll consider the refraction at point B. So here, for a refraction at B, now what will be the value? Here for B, here again I can write this one as sine. Again, the angle of incidence here will be theta c. So it will be sine theta c divided by the angle of refraction for B, it is what? It is 90, is equal to, now see, for this particular refraction at point B, the second medium is cladding and the first medium is core. So here we will write it as the refractive index of second medium, that is mu2, upon that of first medium, that is mu1. So again here we know sine 90 is 1. So ultimately we get the equation as sine theta c is equal to this mu2 upon mu1. Now let's substitute this value in equation number 1. So here put in equation 1. So therefore equation 1 becomes now this mu2 sine theta naught is equal to this mu1 under root 1 minus sine square theta c. Instead of sine theta c, we can write mu2 upon mu1. So this will become mu2 square upon mu1 square. Then simple, it's basic mathematics. If you solve this one, we'll get the value as under root this mu1 square minus mu2 square. So this will be the value of mu naught sine theta naught, and then again here we will get the final equation as sine theta naught will be equal to under root of mu1 square minus mu2 square divided by, whole divided by what? Mu naught, whole divided by mu naught. Again, if the surrounding medium is air, then here I can write for air medium, this value of mu naught will be equal to 1. So here we'll get the final equation as, therefore this sine theta naught is equal to under root mu1 square minus mu2 square, or we can write it as mu1 square minus mu2 square whole bracket to the power 1 by 2. So this is the formula for acceptance angle. This is the final formula for acceptance angle. So that means what? From formula itself, we can say that the acceptance angle, it only depends on the refractive indices of core as well as cladding. It is depending on what? The refractive indices of core and that of the cladding. That of the what? Cladding. And if the surrounding medium is not air, or it is apart from the air or vacuum, then mu naught comes into the picture. Otherwise, it will be just simple as it is. So, my dear students, today we have discussed initially with this acceptance angle, and then what is meant by acceptance cone, and then later on we have derived the mathematical relationship for acceptance angle, and then we get the final value for the equation of theta naught, that is acceptance angle, as sine theta naught will be equal to under root mu1 square minus mu2 square, or we can write it as a mu1 square minus mu2 square whole bracket to the power is what, 1 by 2. So just remember or whatever I said for this particular lecture, because this will help in, like, whenever we will find out the numerical aperture, at that moment all these terms are important as well as necessary. Again, I would like to remind you all that here this acceptance cone, it simply means that whatever light comes into this particular cone, all light is accepted by the optical fiber and then it is guided to for next propagation. So remember that acceptance cone, acceptance angle. I hope you understood all the topics or all the points which I covered today. In next session, we will focus on numerical aperture. Thank you so much.